This video introduces or reviews, pardon me, the exponent rules. So let's start with the basics. We have 2 cubed. This whole expression, or this whole thing, is called a power. And that power is made up of 2 parts. So the power has a base, and it has an exponent. So the exponent up here is 3, and the base was 2. And remember that exponents just mean repeated multiplication. So 2 cubed just means 2 multiplied by itself 3 times. So that's what 2 cubed means. All right, let's move on and look at some of the rules for dealing with exponents. So we'll start by multiplying powers. When we multiply powers, 2 cubed times 2 squared just means 2 multiplied by itself 3 times. So there's 1, 2, and 3. And then 2 squared means 2 multiplied by itself twice. So 2 cubed is this. 2 squared is here. And if we count up the 2's here, there's 1, 2, 3, 4, 5 of them. So another way to write this is 2 to the exponent 5. So if we're multiplying powers with the same base, there's a shortcut to go from here to here, and that shortcut is that if we take any 2 powers with the same base and multiply them together, the result is the same base, but we add the exponents. And the nice thing about these rules is that you can come up with them on your own. You just do a quick little example like this, and then you can see what you get as a result. So it's important to remember that the bases must be the same, though. All right, let's have a look now at dividing powers. Same idea. If we're going to divide powers, let's say we do 2 to the 5 divided by 2 cubed. Well, 2 to the 5 looks like 2 multiplied by itself 5 times. 2 cubed is 2 multiplied by itself 3 times. Now, because we have nothing but multiplication in the numerator, oh, sorry, that's a 3, not a 2. Let's fix that up. Because we have nothing but multiplication in the numerator and nothing but multiplication in the denominator, these are all factors, so we can divide out a factor of 2 from the numerator and the denominator. So 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1, so we're left with 2 squared. And again, we should be able to look here and find a shortcut. The shortcut is that if we have 2 powers with the same base that we're dividing, we keep the base and we subtract the exponents. Nice little shortcut there. All right, let's have a look at 0 exponents. So 0 exponents. In order to do this, I'm going to start not with a 0 exponent. I'm going to start, let's say, with 2 to the 1. Well, 2 to the 1 is 2 multiplied by itself once, which is 2. 2 squared is 4. 2 cubed, 2 times 2 times 2 is 8. If we look at the pattern here, in order to go from one line to the next, we multiply by 2, multiply by 2. So if we want to step backwards, what do we have to multiply by 2 in order to get 2? Well, 2 times 1 is 2, so 2 to the 0 then must be equal to 1. And as it turns out, just about any any base to the exponent 0 is equal to 1. The one stipulation here, the one number that doesn't work, is 0. So as long as a is not 0, anything to the exponent 0 is equal to 1, as long as that anything isn't 0. All right, we can use the same idea to explore negative exponents. So with negative exponents, I'm going to start kind of in the same place. 2 to the 1 we said was 2. 2 squared was 4. 2 cubed was 8. Same idea. Multiply by 2 to get from one step to the next. So what do we need to do to go backwards? Well, we kind of discovered this one already. 2 to the exponent 0 has to equal 1. But what if we want to go back one step further? What about 2 to the negative 1? Well, what do we need to multiply by 2? What do we need to multiply by 2 to get 1? And the answer there is a half. So we didn't quite have enough room for that. And same thing here, 2 to the negative 2. Same idea. What number do we have to multiply by 2 to get a half? Or, another way to put that is that if we take a half and divide it by 2, what number are we going to get? And the answer here is 1/4. And so when we have negative exponents, maybe we'll write this out. I'll just do this last one. 2 to the negative 2 we said was equal to 1/4. But that's also equal to 1 over 2 squared. So notice here, we were able to take the entire power and drop it into the denominator, and the exponent, and only the exponent, became positive. So it turns out for negative exponents, a to the negative m is equal to 1 over a to the m. Notice it's only the exponent whose sign changes. Similarly, we could say that 1 over a to the negative m is equal to a to the m. So if you have a negative exponent, if you move the entire power from the numerator to the denominator, the exponent and only the exponent will become negative. We can do the same thing, moving from the denominator into the numerator, and only the exponent becomes negative. So that's a quick review of dealing with exponents. If you do have, and we didn't talk about this, but it's worth mentioning, if we do have two powers with different bases, there are no rules for dealing with these. There's nothing we can do here. So for example, if we have 2 cubed times 4 squared, well, 4 is maybe not a good example. What if we look at 3 squared? So 2 cubed times 3 squared. We can't simplify that in any way. You know, we can't multiply the bases. We can't add the exponents. These are very different because 2 cubed looks like this, and 3 squared looks like this. So there's nothing that we can do here to simplify that. So remember that these rules for multiplying and dividing powers only apply for powers with the same base. One extra one I just recalled that we didn't mention was powers of powers, so we should probably talk about that. So powers of powers involves things like, let's say, 2 cubed squared. So exponents to exponents. Remember that 2 cubed looks like this, 2 times 2 times 2, and if we square that, that's the same as creating another group of 2 times 2 times 2. Well, we count up our 2's, 1, 2, 3, 4, 5, and 6. So we get 2 to the 6. So when we have powers of powers, so a to the m, all to the n, the shortcut to go directly from here to here is to keep the base and multiply the exponents. So that's a quick summary of exponents, multiplying, dividing, negative exponents, and so on.